Okay, this is a short recording about experiment 6B, D-Day conversion. And this is under the general idea of signal conversion. We all know that computers are ubiquitous at this point in time. However, the real world tends to be analog in nature, that is, continuous variations of whatever it might be, temperature, pressure, luminescence, anything you could think of. It's a continuous range. However, our computers only deal with binary data, so we digitize things. This one, again, experiment 6B, talks about how we go back from the digital to the analog world. So I've got circuit maker open here, and as you can see, there's a group of switches, 8 of them to be exact, on the left-hand side. U1 is a 8-bit DAC, digital analog converter, and it's powered by, well, nothing in this case. Turns out the power supply connections are suppressed, but there is a V reference plus and V reference minus. The latter goes to ground. V1 is 2.56 plus 2.56 volts, which is the plus V reference. So on the left-hand side, you see D7 through D0 going downward on the integrated circuit. And then again, there's a bunch of switches. So over here, if I bring the little cursor over, you can see this switch is open, closed, 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 open, open, closed, open. And they're all connected to plus 5 volts, which is in the digital world, rather, a 1. So actually what the value of the input here is 0, 1, 1, 1, 0, 0, 1, 0, with this one being the least significant bit and this the most significant bit. So you read it from left to right, starting with D7 going towards D0. So I'm going to run this, and I run it. What happens, I see that I've got 1.140 volts on my voltmeter. So I'm going to enter that into the data sheet here, the experiment. And again, my input is 0, 1, 1, 1, 0, 0, 1, 0. I'll show you this. I have to make another video with my document camera to show the data. That's okay later on. So now the next part of the experiment, part B, is to change the input data word to the values shown in the following table. So I've got the data words in hex. So I will take and convert those. And again, I'll show you this in another video. So the first one is 5 zeros followed by 3 ones. So I'll stop this guy. And, well, I guess I can go this way, and I can take and change my switches. So let me put them all to 1. And then again, I want to have the first 5 zeros. I'll open that one, that one, that one, that one, and that one, and close those 3. So that is 0, 0, 0, 0, 0, 1, 1, 1, which in hexadecimal, the first 4 digits here would be all zeros, or 0 in hex. And this would be 0, 1, 1, 1, which is 7 in hex, or 0, 7 in hexadecimal. So I'll run it now, and we get 70 millivolts as an output. I'm going to enter that into my table and show you that in another video. The next one is 0B, which is 4 zeros followed by 1, 0, 1, 1. So I'm going to stop this guy and go over here. I can only change them when it's running. So, oops, I want that one to be the first 4. I want to be zeros. Then I want, well, actually, this to be a 1, this to be a 0, and these to be 1s. So that's 0, 0, 0, 0, 1, 0, 1, 1, which I believe is 0B. So let me take and I get 110 millivolts, which I'll write down. Next one is 0 F. So that one turns out to be, again, I can see here. I can change these guys. The first 4 is 0, then F is all ones. Oops, not let me change it, so I guess I got to do that. Now and change it maybe. Yep, there we go. So 4 zeros and 4 ones is 0F. And I run it. You got 150 millivolts. The next one is 1 0 in hex, which is 0 0 0 1 0 0 0 0. So I'm going to have 3 zeros, which this guy's going to be a 1, and these are all going to be 0. That one doesn't like to change. I don't know what the story is with that guy. So going, I guess we got to run them, stop them. Who knows? Yeah, open it up there. So now we have 0 0 0 1 0 0 0 0, which is 1 0 in hexadecimal. Run this guy, 160 millivolts. The next one is AA. A is 1 0 1 0 1 0 1 0. So I'm going to take and set the switches again. 1 0 1 0 1 0 1. That one doesn't like to be switched. Let's see if I can do it now. Yeah, there we go. So 1 0 1 0 1 0 1 0, or AA in hexadecimal. Let's run it. I get 1.7 volts. Next one is C2. C is 1 1 0 0. 2 is 0 0 1 0. So let's see if I can switch these. So 1 1. That one doesn't like to go. So no. We got to take in 1 1 0 0. 2 more zeros. This guy, that guy, and a 1 and a 0. So I think this is 1 1 0 0, which is C. 0 0 1 0, which is 2. So this should be C2 in hex. And let's take it and run it. You get 1.940 volts. 1.940. Next one is F8. So that's 4 ones followed by 1 0 0 0. And again, you could go to Google and take in kind of vast Google what F8 is in hex, or you can use the calculator here in Windows. The calculator has a mode that you can take and turn it into a binary to hex converter, or a decimal to hex converter, and so on. So what do we want here? We want 4 ones, and that one I got to cross and go back. 4 ones, and then we want 1 here, followed by 3 zeros. Okay, so let's run this guy. 2.480 volts. Last one's FF, which is all ones. So let's see if we can do that. Oh, we're going to allow me to do it this time. All ones, and we'll run it. 2.550. So that's part B. The next part is we want to change this voltage here, the reference voltage, to 5.12 volts. So let's take and do that. Oops, let's be deleted. I don't want to delete it. I don't want to change it. It's not let me do that. Maybe it's running, so stop it. Not being very cooperative. I shouldn't have this probe up when it's stopped. It's going to be problematic, possibly. Let's see if again I can refresh screen, maybe. It's not allowing me to do that. So what I'm going to do, I'm going to exit out. I'm gonna go back and reopen. Let's see, where was it? The DAC, this guy here. So let's see now if I can change this guy. Yeah, data device data. Sometimes circuit maker can be very persnickety. Okay, so now it's 5.12. So I've taken the reference voltage, doubled it. So now what I do is change the value of, okay. Repeat the procedure of the prior section, fill in the values of DAC output in table 3 below. So now I'm going to take and have different data words. 08 is 4 zeros followed by a 1 and 3 zeros. So let's see if we can do that. So 4 zeros, there's 4 zeros, a 1 and 3 zeros. And I'll run it. 160 millivolts. Next one is 0D. 0D is 4 zeros followed by 1, 1, 0, 1, I believe. 15, I think that's it. So let's take in, we want 4 zeros. We got 4 zeros there. 1, 1, 0, 1. I believe that's 4D. If I make an error in here, you'll catch it. Let's run it. 260 millivolts. Next one is 1, 0 in hex, which is 0, 0, 3 zeros followed by 1, followed by 4 zeros. So let's see if we can do this. 0, 0, 0, that's a 1, followed by all zeros. Let's run this guy, 320 millivolts. Next one's 1F. That's 3 zeros followed by 1, followed by 4 ones. So what happens? We get the first 3, and these are all 1s. Of course, it's not letting me do that. So 3 zeros followed by 4 ones is 1F. Let's run it. 620 millivolts. Next one's BA. So I goofed up the one before. I'm looking, the one that was 0D. Got to go back to that. I just came to mind. 0D is 0. That's 4 zeros followed by 1, 1, 1. No, I think I got that one right now. I think about it. B. Let's try B. B is 1, 0, 1, 1. 8 and 3 is, and then A is 1, 0, 1, 0. So let's, again, if I've made a mistake, you'll find it. So this guy is 1, 0, 1, 1. This guy's 1, 0, 1, 0. This is, I think, BA. We'll take it. Run BA. BA gives me 3 volts, 3.720 volts. Next one, CF. C is 1100, followed by all zeros, so it's going to be 1100, all ones. I think that's CF and X. I'll run it. 4.14 volts. FA is the next one. FA is going to be 4 ones followed by 1010. So let's see, 4 ones. No, it doesn't like me doing that. So we go here, 4 ones followed by 1010. And we run that guy. 5 volts exactly on the nose. The last one's FF, which is all ones. See if we can do that. Yeah, I like that. And you run it, and you get 5.1 volts. Okay, so those are all the measurements for experiment 6B D-Day converter. So I'll stop this video at this time. At least I'll try to.